Hi, my name is Ashish Panthi and this is my junior seminar final project presentation. My project is an automated pipeline that takes a topic from Google Sheet and turns it into a short TikTok style educational video with captions using n8n OpenAI models and FFmpeg. I'll briefly explain why I built this, show you the high level design, walk through a live demo of workflow, and then wrap up with results, one key challenge and future work. Here's the plan for this presentation. First, I'll talk about motivation and objectives of the project. Then I'll show the high-level architecture so you can see how the pieces fit together. After that, I'll mainly focus on a demo of actual workflow running. And finally, I'll come back to talk about results, challenges, what I learned, and future improvements. Short form educational videos are everywhere now, but making them manually is slow. For each video, you usually have to write the script, figure out visuals, generate a edit video, add captions, and repeat that for every topic. I wanted to automate as much of that process as possible. So my objective were to build a pipeline that goes from a Google Sheet row to finished vertical explainer video, to make it reusable or different computer science topics, and to use it as a way to practice workflow orchestration with n8n OpenAI models and FFmpeg. This slide shows the high-level architecture of the system. It starts with Google Sheet row that contains the topic, angle, and keywords. n8n reads that row and sends the data to an OpenAI model to generate a structured script with a hook, bit, and a call to action. A normalized code turns that script into two things: a single narration string and an SRT caption string. A Sora video node generates a short vertical MP4 based on that script. The workflow then writes the video and SRT to /temp and uses FFmpeg to burn the subtitles into the video. The final result is an MP4 file that's ready to upload. Instead of just talking about it, I'll switch over now and show you how this looks in practice. I'll start with the Google Sheet that drives this workflow. The row here represents one potential video. One example, this row has an ID, the topic, an angle, and some keywords like virtual memory, paging, page table, page fault. The n8n workflow will read from this row and generate a script, a Sora video, and then finally MP4 from it. Now I will switch to n8n, which is the workflow automation tool I'm using. This is the full workflow at high level. It starts with Google Sheet. Uh, uh, then it calls OpenAI model to generate the script. Then it goes to normalized code that builds narration text and SRT captions. This part generates video. This part generates captions. We write them to memory. We combine them, and we give the video back. So this node is the it generates script. It takes topic, angle. So it takes topic here like as an input, topic, angle, keywords from sheet rows, and passes them to OpenAI model with a prompt that basically says write a short educational script or vertical video with a hook, several bits, and a call to action. The model returns a JSON object. So this is output is a JSON object with a hook, a list of bits with both text and on-screen fields, like so text and the on-screen fields, and a CTA. That structure is what next nodes uses to build narration and subtitles. This node is called normalize and it's a JavaScript code. Its job is to take the JSON object and produce two things for the rest of the pipeline. First, it builds a CTA. It builds a single narration string called TTS text by joining the hook, all of the bit text and CTA. Second, it builds an SRT caption using SRT. It creates caption blocks, assign timestamps across about 12 seconds, and uh, formats them in funcs like this format. This output looks like. Those two field TTS and SRT are what makes the caption consistent with the script. So this is the node where we generate video. So this is the input we pass. This is the input we pass. This is the OpenAI Sora model for which we call API to make generate video. This is our prompt to generate that video. So this is our prompt, and the output from this node is MP3 video. It looks something
Ever
like this.
wonder how your computer runs multiple apps smoothly? Virtual memory allows processes to
So
use
this
more
is the
memory
video
than
we
physical RAM.
created.
Paging divides memory into small.
Uh, the thing is like this is not bad, right? But we can still but it doesn't have captions on it, so we also want to add captions to it. So this part generate captions for our file. uh, so here we convert it to an actual file. It looks something like this. So this is what that file with timestamp looks like. After both of these nodes, we write it to device memory, like the device we are in. So we write it with the name of this. We write to file disk file. It's so that even if n8n no longer exists, so that our data exists in a physical memory. After we have both video and audio, we again merge them and we execute this command. What it does is it combines both audio and video and captions together. Conceptually, this is takes OS video as an input, takes subtitle as an input, then combine them. That output is the final video with born in subtitles. These were the input this part got, and here is what final output looks like. So after we combine audio and video, we write it again to the disk of this device, and we can download it from here. So this is the file I downloaded. It opens something like this. Now you can see we have, if we plug, we already had the video explaining, but now we also have the captions.
Ever wonder how your computer runs multiple apps smoothly? Virtual memory allows processes to use more memory than physical RAM. Paging divides memory into small blocks called pages. A page table keeps track of where each page is stored. When a page isn't in RAM, a page falls.
So this is the total flow. Let's go back to our slides. In terms of preliminary results, I have a working end-to-end pipeline for at least one topic. What is virtual memory? The pipeline goes from seed, script, normalized, Sora, FFmpeg to final caption MP4. The video is short and that's ready to upload to TikTok. So core idea: automating short form explainer using this stack works in practice. The main missing piece is automatic publishing to TikTok. The natural next step will be, after generating final MP4, instead of saving it here, my next step will be like something like to write into TikTok from this node only, like instead the video here, like directly publishing it to TikTok. However, TikTok's official upload API access is limited to business accounts and specific partners. I currently have a personal account, and getting business level access will require legal and administrative steps that are outside of scope of this course. Because of that platform limitation, the system now stops at generating the final MP4, and uploading that to TikTok is still a manual step. This project taught me a lot about gluing systems together. On technical sides, I learned how to orchestrate multiple tools using n8n, how to design prompts and structured output so each node knows what fields to expect, and how to integrate AI-generated content with traditional tools like FFmpeg and local file system. I also got better at debugging end-to-end workflows, tracking down issues with file paths, binary data, and shell commands, rather than just debugging isolated functions. Uh, For future work, I'd like to add authenticated TikTok or Instagram upload once I have access to right APIs, support longer scripts and more formats such as YouTube Shorts, and create a batch mode that can generate many videos from multiple seed sources once. Even in its correct form, the project already demonstrated a full journey from structured topic in spreadsheet to rendered caption video. Thank you for watching my presentation.